Okay, what we have here are the velocity versus time graphs that I have made in accordance to these distance versus time graphs. Starting out with the first one, you can see that the slope of this graph is the same everywhere. It's consistently increasing, which means that the velocity is going to stay the same in the positive direction. So the velocity versus time chart would look something like that. Just a flat line to show that the velocity is positive and going the same direction, in the positive direction. Going on to the next one, our distance versus time graph looks like that, which means that since the distance isn't getting any higher or lower, it means there is no velocity, which means the velocity graph would look like that. There's nothing. It's just the line would be right where the zero line is, but I didn't try and put a line over a line. Going over to the third one, you can see the distance versus time graph is similar to the first one, but this graph is decreasing slowly, which means you're going to have a steady negative velocity, which means that the velocity versus time graph would look like that. And there's the line right there. It just stays the same negative velocity. Going on to the next one, you can see that the distance is steadily increasing, which means that the velocity is going to be steadily increasing as well in the positive direction. So the velocity versus time graph would just be a straight line like that, starting out at zero and just consistently getting faster. On to the next one. We have here, this one starts out in the going in the negative direction. It starts out slowly and the speed steadily increases in the negative direction. So the velocity versus time graph would start out at zero and start negative. The velocity starts out slower, but then it gets faster and eventually levels off. Going on to the next one, what we have here is part of cosines. So I used negative sign to help me draw the velocity versus time graph, which would look something like that. This point here where the velocity starts to become negative would correspond with this point right here, which is where the velocity becomes negative. Going on to the next one, right here, the velocity starts out consistently positive. The velocity stays the same in the positive direction, which is that little part right there, and then after a while it stops moving entirely. So the graph for that would look like that. Here's the part where the velocity is consistently increasing, and